This is a regular pentagon. Construct a square with the same area as this pentagon. Are you trying to divide the shape into multiple parts and rearrange them? It seems possible, but it's not easy. There's a universal method to construct a square with the same area as a given shape at any time. It is to construct a rectangle with the same area as that shape. Here is a rectangle. This length is A. This length is B. So its area is AB. Let's construct a square with the same area as this rectangle. Extend this side. Draw a circle with this side as the radius. An intersection point is created. This length and this length are the same. Draw the perpendicular bisector of this segment. The intersection point is the center of the new circle. Extend this segment to find the intersection with the circle. Let's call this line segment C. This line segment is one side of a square with the same area as the rectangle. Why is that? Look at this diagram. Especially pay attention to this triangle. This is the diameter of the circle. So this angle is a right angle. That's because an inscribed angle subtended by a semicircle is always a right angle. This angle is alpha. This angle is beta. Their sum is 90 degrees. Since this is a right triangle, this angle is beta. Since this is also a right triangle, this angle is alpha. Thus, these three triangles are similar. The ratios of the lengths of corresponding sides are the same. From this, we get C squared equals AB. But what was AB? It was the area of the rectangle. Therefore, C squared represents the area of a square that has the same area as the rectangle. A square with the side length C has the same area as the rectangle. Now, let's go back to the original problem. The goal was to construct a square with the same area as a regular pentagon. To do that, we first need to construct a rectangle with the same area as the pentagon. How can we do that? Draw two diagonals like this. The pentagon is now divided into three triangles. Extend this side. Draw a line passing through this point that is parallel to this line. An intersection point and a triangle are created. The area of this triangle is equal to the area of this triangle. That's because their bases and heights are the same. So this quadrilateral has the same area as the regular pentagon. Again, draw a line passing through this point that is parallel to this line. Another intersection and another triangle are created. The area of this triangle is equal to the area of this triangle. Their bases and heights are the same. Therefore, this triangle has the same area as the regular pentagon. Now, using this triangle, let's construct a rectangle with the same area as the pentagon. Draw a perpendicular line passing through this point. Draw the perpendicular bisector of this segment. This part is congruent to this part. This part is also congruent to this part. This rectangle has the same area as the triangle. Thus, it also has the same area as the regular pentagon. Eventually, we have found the rectangle we wanted. Now, we can construct a square with the same area as this rectangle. Extend this side. Draw a circle to find the intersection point. Draw the perpendicular bisector of this segment. Draw a circle centered at this point. Extend this segment. Find the intersection of this line and the circle. Construct a square with this length as one side. This is the square with the same area as the regular pentagon. Great job!